So for the first one here, this is a simple box. Need to find its volume. You could just do length times width times height would work because it's a box, but we've been doing the area of a base times a height. So for a box, usually the base is just the bottom. So the area of the base of this is going to be just 30 inches by 24 inches, which is 720 inches squared. So then to use that to find the volume will be the 720 square inches times that height of 12 inches, which is going to be what? What's that? 8,640 inches cubed. That's our volume. Anybody have any questions so far? Now, question 2 has to convert that to cubic feet. So we put it over 1. Cubic inches go on bottom, so they'll cancel out. Feet are larger, so it's 1 cubic foot. How many cubic inches are in a cubic foot? 1,728. Very good. Cubic inches cancel out. Is it exactly 5? Cool. So it's 5 cubic feet. Over here, number 3, the base is not the bottom anymore. The base is the triangle. Remember we said that a volume is created by taking a shape and moving it in a perpendicular direction. That triangle is the shape that is moved to create this solid object. So the area of that base is going to be 8 feet by 15 feet divided by 2 because it's a triangle. So 60 square feet. So then the volume will be 60 square feet times the 30 feet of length, otherwise known as 1,800 cubic feet. So then number 4 here, convert that into cubic yards. So cubic yards will be on top. 1 cubic yard is 27 cubic feet. They cancel out, and that becomes what? 200 cubic yards. Does that look right? I was going to say 66.67. 66.67 cubic yards. 8 divided by 9 instead of 27. Okay. So that's our volume. I want to then talk about something called surface area. Surface area for a box So let's say that's our box here. Let's give this 10 feet, 8 feet, 6 feet. For a box, I could find the surface area just by finding the area of each little rectangle. There are how many rectangles that make up the surface of a box? 6 of them, but they come in pairs. I'll label them B for bases, top and bottom. Those are each 10 feet by 8 feet, or 80 square feet. And there's 2 of them. I'll label these sides A and A. Those are 8 by 6. So those are both 48 square feet. Then, of course, you got the front and the back, C and C we'll call them, which are 10 by 6, or 60 square feet. We add that all up, we're going to get, what, 376 6 square feet, I believe. That is the surface area. Well, for a box, that works just fine. But what I want to do is I want to break it up and make it a little bit more straightforward. And to do that, I'm actually going to define an extra thing called lateral surface area, or often just referred to as lateral area. Lateral surfaces, lateral area can be defined in a couple of different ways. First of all, lateral surfaces are the rectangles that connect the bases. And not necessarily even rectangles, it can be any shapes. It's just the surfaces that connect the bases. So up here we've got the base on bottom and we got the base on top. The lateral area are those 4 rectangles that wrap around the sides. A second definition of lateral surface area or lateral area is just all area except the bases. So again, that would give us those same surfaces. Well, if I look at this defined surface area then, total surface area, it's just going to equal the area of the bases. Notice I put that S in parentheses there because we will run into shapes that only have one base instead of 2, plus the lateral area. Well, the area of the base of this thing we've already done. The area of the base was 10 feet by 8 feet. That's 80 square feet. And there were 2 of them, so we had to add that in twice. Well, that was just our first 2 calculations up here, right? Our first calculation, our first 2 areas. For the lateral area, what I'm going to do is this. I'm going to slice this right up the corner. Then I'm going to take those rectangles, I'm going to lay them out in one big long line. So here are my lateral surfaces. And 10 by 8. This height here is still just the 6 feet that the regular object was tall. But this is 10 feet, 8 feet, 10 feet, and 8 feet, which of course gives us a total 36 feet. That 36 feet is just 10 plus 8 plus 10 plus 8. It's just the perimeter of our base. So the lateral surface area, lateral area, is just equal to the perimeter of the base times the height. So the perimeter of the base here is 36 feet, times 6 feet of height is what, 216 square feet? And that adds up to be 376 square feet. That's total surface area. That is sometimes referred to as total surface area, sometimes just referred to as surface area. But that is the area, the whole surface area of this object. Notice I came up with the same answer either way. For a box, it's about the same amount of work either way. But there are shapes that we will run into where it's not quite so simple. So a shape like this, if I want to find the surface area, first thing I need to do is find, well, the area of the base. We'll need the perimeter of the base too. You're right. So the area of the base here is going to be 8 feet by 15 feet divided by 2, which is 60 square feet. Are there one base or two bases? One here and one there. So there is 60 square feet again on the other end. Now you're right. For the lateral area, the first thing we need to know is the perimeter of the base. Well, we've got 8 plus 15. We need to know that side. How can we find that side? Perfect. 8 squared plus 15 squared equals, we'll call that x squared. At this point, I'm going to leave it up to you guys. I have faith that you guys can do that to find that distance is 17. So the perimeter of the base is 8 feet plus 15 feet plus 17 feet, which is 40 feet. So the lateral area is at 40 feet times the 25 feet of height, which is 1,000, right? Square feet. So that gives us a total surface area, 1,120 square feet. There is a word for these kind of shapes, by the way. It's called a prism. A prism is just any shape that has, or any solid object that has polygons for bases and then rectangles for the lateral surfaces. That's what a prism is. Okay, so what we have here, 8 feet, 10 feet, 10 feet. I want to find the surface area. Well, and of course, the key to working with this is working with the base. The base is this bottom piece, not just because it's on bottom, but because that is the shape that could be, pull through it, dragged through it. You are right. So first I want to find the area of that base. Now I'm going to do it in two pieces. I've got the rectangle, which is how big? 10 feet by 8 feet, which is 80 square feet. Second, we have the half circle. What's its radius? 4. Perfect. 5 times 4 squared divided by 2, which is going to give us 25.12 square feet. So that area of that base is 105.12 square feet. So when I'm looking at surface area, I have that in there twice. We should be pretty good at finding that. I mean, that's what we would have to start if we were finding the volume of this thing too. Now for the lateral area, the big thing we need to know, of course, is the perimeter of the base. Well, we've got This is 10 feet. This is 8 feet. This is 10 feet. We need to know this. That is going to be half of the circumference of a circle, right? Pi times diameter, pi times 8 divided by 2, which is 12.56. So that adds up to 40.56 feet. So now my lateral area is that perimeter of the base, 40.56 feet, times that height, 10 feet, which is 405.6 square feet. So that all adds up to 615.84 square feet. What's that? So that's my surface area. That's actually figured in. Yep. Because this here is the area of the bottom, right? This is the area of the top. This here takes in that whole part that wraps around. The lateral area is all that at once. Think of it as we sliced this here. We sliced that right there and we rolled it out. We had the rectangle. We had that portion that was curved. We had the rectangle on back, and we had the rectangle on the end. Well, this was the 10 feet high. This distance here was just the 40.56 square feet, or 40.56 feet. So yeah, you get all those surfaces that wrap around it all at once. Well, this one had that curved surface in it right here. And that curved surface is exactly the reason why we define lateral area and we use that perimeter of the base times the height. Because we'll run into shapes like this one. And instead of having to memorize a special formula for cylinders, this is going to be just like any other shape that we've worked with. Let's say that's 10 inches of diameter across the bottom and 20 inches of height. Let's do the volume first, just to review. First step in finding the volume is what? Area of the base. Same as the first step in finding the surface area. So we've got a 5-inch radius, so it's pi times 5 squared is 78.5 square inches. So then the volume, 78.5 square inches times 20 inches of height. Is that 1,570 cubic inches? Does that look right? Close enough. For surface area, we've got the area of the base, which you already found for volume up there. And of course, it's going to be in there twice. We already found that area of the base. We need to find the lateral area. For the lateral area, of course, the first thing we need is my pen to work, for one. What's the first thing we need to know for lateral area? Perimeter of the base. Very good. So the perimeter of the base here is just the circumference of the circle. Pi times 10, which is 31.4 inches. So then the lateral area is that 31.4 inches times 20 inches of height, which is 628 inches squared. which adds up to be 785 square inches of total surface area. What do you think? I'm seeing some looks out there that say you're not so sure. Purple? This year? Added those three. Well, let's have you guys try one. Just call me Todd in the classroom. There's a lightning bolt coming my way. Try to find the surface area of that in your notes. We'll give you a couple minutes. So you start out by finding the area of the base. How are you going to find the area of the base? Pi times 8 squared, which turns out to be 200.96 inches squared. There will be two of those. You are correct. Then what? Yeah, for the lateral area, you have to find the perimeter of the base, which is going to be that, that circumference. Actually, I'm fighting off a sneeze, and for some reason it's making me yawn. Pi times 16, which is 50.24. That's inches. So then the lateral area is the 50.24 times 25, which is what? Oh yeah, 25 feet, not inches. Okay, let's change that to inches. Does that make it easier? Okay, so what do we get there then? 256. So we add that up, we have 1,657.92. Does that look right? Let's see what would change there. Yeah. You might be off that far by using pi at the pi key. Because this would be 201.02 or something like that. You guys got the picture though, right? Okay. In the big book, page 609 through 610, exercise 28-4.